Okay, so for number one, we are talking about it's a word problem. So it says a required exam to obtain a professional license or renewal of a current license has two sections, a general knowledge section and a specialization section. You can score a maximum of 1,200 points. For obtaining renewal, the state where you work requires specialization score of at least 475. Let X represent the score on the general knowledge section and Y represent the score on the specialization section. Write a system that models the scores that meets the school's requirements. Oops. Okay, so we want to write a system. So they give us their two variables. They said that X is our our score on the general knowledge section. So our general knowledge score, you say GK. And then Y is the score on the specialization section. So specialization score. So they want us to write a system. So let's see. So they give us a few things. So they say you can score a maximum of 1,200 points. And then they also say the state where you work requires a specialization score of at least 475. So for our Y, so I'm going to use that part first. So for the Y, Y is the specialization score. So Y has to be at least 475. So we know that we could be 475 or greater than 475, because if I'm at least 475, I could get 475, or I could get 500. I could get anything above that. And so we want to be greater than 475, and we could be equal to 475 because it's at least, so we could have 475 as our score. So then for the other one, the score of 1,200 points would come from like both of the test scores added up together. So X plus Y is going to be a max of 1,200. So if we're at a max of 1,200, that means that we cannot get a score that is bigger than 1,200. So we want less than the 1,200, and we could get 1,200 points. That's like the max. So we want to be equal to. So yeah, so that would be our system for that one. Okay, so for the next few, these are our absolute value inequalities from our first lesson. So when we're doing these, we want to, like, our steps for these is to, first we want to make sure our bars are by themselves. So we want to get the absolute value bars completely by themselves first. And then we kind of decide, like, all right, is it going to be no solution, all reals, or do I need to actually solve it out? So for part A, I noticed that there's nothing around my bars. So I could go ahead, and what we do is once they're by themselves, we drop the bars. So we say 6 minus 3x greater than 21, or sorry, greater than or equal to. And then we also do 6 minus 3x. We flip it, less than or equal to, and then we make it negative. Right, so they want us to solve. So first thing I would do would be, I want to subtract this 6. So negative 3x is greater than or equal to 15. And then we would divide both sides by negative 3. So x, and remember when we divide both sides by a negative, when we're talking about an inequality, the inequality flips, and then 15 divided by negative 3 is negative 5. All right, for the other one, well, same steps. So we want to first subtract the 6. So negative 3x less than or equal to negative 27. And then we divide both sides by negative 3. So x, and again, we were dividing by negative, so it'll flip the inequality. Negative 27 divided by negative 3 is positive 9. Okay, so we want to graph. It wants us to graph these. No, it doesn't want to. Oh, okay, so it doesn't want us to graph. It wants us to write an inequality, which we did, and interval notation. Okay, so we want everything less than -5 or bigger than 9. So I might just draw a graph just to help me with my interval notation. So if I think about my graph, we're at -5 and 9. Excuse me. All right, so they're both equal to, so we want closed circles. And then we want less than the 5, so we would shade to the left. And then we want everything bigger than the 9, so we would shade to the right. So I'm trying to write this in interval notation. We always read from left to right. So for the -5, we want everything less than -5. So we want all those numbers from -infinity up until we get to -5. And -5 is included, right? We have a closed circle, so we're going to put a bracket around that. And then we jump, so we want our union. So we jump to 9. 9 is also included, so we put a bracket, and then we just want everything bigger than 9, so we go off to positive infinity. And we always have parentheses around our infinities because we can't be equal to infinity. All right, so part B. So first things first, we want to make sure the bars are by themselves. So I notice there's a -9 in front of my bars. So I do need to get rid of that. So the -9 is being multiplied by the bars. So we divide by -9. So that would make this x plus 4. When we divide both sides by a negative, inequality flips, and the -45 divided by -9 would be +5. All right, so once we get the bars by themselves, we drop the bars and then solve. So we do x plus 4 is less than or equal to 5. And then we do x plus 4, flip it, and then we greater than or equal to -5. All right, so we would subtract the 4. So x is less than or equal to 1 for our first solution, and then subtract the 4. So x is greater than or equal to -9 for our other solution, -9. All right, so for these, they want us to do interval notation. So I'm going to draw a little graph just to help me. So I have a solution at 1. Sorry, I have a solution at 1 and then -9. So we want closed circles again for these because they're equal to. And then we want less than 1 and greater than -9. So this one would be an and, so it's in between -9 and 1. So for our interval notation, we lead left to right. So we start getting numbers at -9, and it's a closed circle, so we put a bracket. And then our interval stretches up until 1, and then another closed bracket because of closed circle. All right, part C. All right, so first things first, get your bars by themselves. So I need to get rid of this +4 in the front, so I'm going to subtract it. So x minus 5 less than -2. Now I noticed that once I got here, I am less than a negative number, which is impossible when we're talking about our absolute values. So in this case, this one would be no solution, right? Because we cannot, with our absolute values, can't be less than a negative number. All right, part D, we want to get rid of the -3 first. So we divide both sides by -3. So that would cancel, and then we get x plus 2. We divided both sides by a negative, so the inequality will flip, and then 12 divided by -3 is -4. So this one is a situation where we are greater than a negative, and absolute values are always bigger than negatives. Right, our absolute values are always positive, so there's never a situation where this one would be not negative. So that would be all real. This would be all real numbers. And if we want to write all real numbers in interval notation, or that is just -infinity to +infinity. All right, so next up we have our quadratic inequalities, our one variable quadratic inequalities. So these don't have a y in them. So we can't like graph these or anything. So we solve them like we would solve quadratics, like we factor. And then we had to like test the points with these. So for 3a, we want to looks like there's a negative in the front. So I'm going to factor out a negative to help me make that x squared plus 17x plus 72 less than 0. So then we want to think of two numbers we want to think of two numbers that multiply to be 72 and add to be 17. They're both going to be positive because we're multiplying to be positive, adding to be positive. I would think 9 and 8. And then whenever you pull out a negative, like that doesn't affect your answers. So if we always do the opposite sign of whatever's in the parentheses. So our two x values would be -9 and -8. So if we want to go ahead and graph, we want -9 and -8. Just kind of make this a little bit smaller. So we want -9, -8. All right, so then we know that these are going to be open circles, right? Because we are just a less than in our original, so we want open circles. So now it's kind of up to like we have to figure out where we need to shade. So this is where we test. So we always test like in the different intervals. So we want to test first, we're going to test a number down here. So a number that is less than -9 to see if we're going to shade over there. So I'm going to just do the next one. I'm going to do -10. So we plug that into our original problem and see like, does that work? So if I plugged in -10, that would give me -10 squared. So I'm replacing x with -10. So -17 times -10 minus 72 less than 0. So that would be -10 squared is 100 with the negative in front. So -100. -17 times -10 would be a positive 170 minus 72. Okay, so -100 plus 170 would be -70. 170 -100 minus 72. Yeah, so that would be a negative. Yeah, this would be -2 less than 0, which does work. All right, so we already know that this portion down here is going to work because -10 works. Right. Let's also, so I'm going to test something up here bigger than -8, sorry. And if it's bigger than -8, I'm going to choose a nice one. I'm going to do 0 because that's bigger than -8. And we'll see if that works. So plugging in 0, it would be -0 squared minus 17 times 0 minus 72 less than 0. So this would be 0 minus 0 minus 72 less than 0. So that'd be -72 less than 0, which does work. So we know that this over here, we want to shade to the right. All right, so if we know that that works, then this part right here in the middle will not work. So we could test one in the middle, but this shouldn't be like an all real numbers kind of situation. So you could test like -8.5, but it shouldn't work. So yeah. All right, so let's do part B now. All right, so this one doesn't have a good UCF or anything. So I'm gonna go ahead and factor. So we think of two numbers that multiply to be -63. And then add to be +2. Now, one will be negative, one will be positive because we're multiplying to be a negative number. So I'm thinking like 9 and 7, and probably be +9, -7. All right, so our two answers will be -9 and +7. right, so if we're graphing, huge graph, we want -9, +7. We are just less than, so we want open circles. All right, so let's test. So let's start, let's just go left from right. So I'm gonna do this left part here. So let's test x equals -10 first and see what happens. Okay, so plugging it in, that would be -10 squared plus 2 times -10 minus 63 less than 0. So that would be 100 minus 20 minus 63 less than 0. So 100 minus 20 minus 63 is going to be 17. And that is not less than 0. So that does not work. So we do not want to shade over here less than our -9 because it doesn't work when we test. All right, let's move on to the next one. Because if it doesn't, so like if it doesn't shade over here, like less than -9, it probably won't shade over here because usually it's either like between or they're going out. So let's test in between and see if that works. So between -9 and 7, let's test x equals 0. So if I plug 0 in, so 0 squared plus 2 times 0 minus 63 less than 0. So this would be 0 plus 0 minus 63 less than 0. So -63 less than 0, which does work. So I know that between -9 and 7, that's going to work. So I can kind of stop there because I know that this part of this other part shouldn't work if I test it. Oh, and they want us to write our answers in interval notation. Okay, let's do that for part B, and then I'll go back and do part A. So interval notation, we're starting at -9 for this one. It's an open circle, so we want a parentheses for this one. And then our interval goes up to 7, and it'll be another open parentheses because it's an open circle. Okay, so part A, going back to that one, sorry, I forgot about this interval notation for this one. We're coming from -infinity up until 9. I'm trying to like figure out where I can write this. So we're coming from -infinity up until -9, and it's an open circle, so we want a parentheses. And then our interval jumps to 8, so we want our union, and then we start at -8. We don't include it, we put a parentheses because it's open circle, and then everything on the right side goes off to positive infinity. Okay, part C. So for this one, I noticed I do have something on the right side. So before we factor, remember we always have to make everything on one side of the equation. So we need to move the 24 over to the right, or sorry, the left side. So we're going to subtract it because it's positive and make this x squared plus 2x minus 24 greater than or equal to 0. So make sure you're not trying to factor until everything is on one side. So we want to think of two numbers that multiply to be -24 and add to be +2. One will be positive, one will be negative because we're multiplying to get a negative. So I'm thinking probably 6 and 4 and +6, -4. That would work. So we want -6 and +4, opposite signs. That's going to be our answers. All right, so let's graph to help. So we want -6 and 4. Now these are going to be closed circles because we are equal to. So we want closed at -6 and closed at 4. All right, so we want to test. So I'm going to test, start left to right. So I'm going to test less than -6. So I'm going to just do -10 because I've been doing that. You could do -7, you could do -8, doesn't matter. Just something less than -6. All right, so this will be -10 squared plus 2 times -10 minus 24 greater than or equal to 0. All right, so that would be 100 minus 20 minus 24. Yeah, that'll work. 100 minus 44. Yeah, for sure. 56. So that's gonna work. So we're gonna shade over here less than -6. So I know that if that works, then the middle part is not going to work, and that probably this bigger than 4 is gonna work. So let's test something bigger than 4. Let's do positive 10. So let's do positive x equals positive 10. So we're gonna have 10 squared plus 2 times 10 minus 24 greater than or equal to 0. And I'm plugging into this one. You could technically, I guess, plug into the original equation. It doesn't really matter. It would just be like that side would have to be greater than 44. Okay, so 100 plus 20 minus 24. Oh yeah, that's definitely gonna work. Right, 120 minus 24 would be 96. Yeah, so that works too. So yeah, we want greater than the 4. All right, so if we want to do interval notation for this one, I'm gonna go up here because I'm like running out of room for these. We want everything less than -6, so we want negative infinity up until -6, and we have a closed circle this time, so we want a bracket because we include -6. And then our interval jumps to 4 and another closed circle, so we want our second interval to be starting at 4, and we include it, so we want a bracket. And then we want everything bigger than 4, so positive infinity. Okay, so then we got into our quadratic inequalities that are equal to y. So these we can graph easily. So so these, like, the difference between these is these, like in part 3, in question 3, they're not equal to y, so we can't graph them. So these are, this one, number 4, is equal to y. So I'm gonna graph and then I'm gonna answer the questions because the graph will help me answer these questions. So with these, this one is factored form already, so we could easily see the x-intercepts from this form. So we take our factors and set them equal to 0, and that's how we get our x-intercepts. So the first one we would add the 5, so negative x equals 5, so x equals, divide both sides by a negative, so x equals -5. And this other one we would subtract the 9, so x equals -9. So we have two x-intercepts at -5, so I'm just gonna go draw them real quick on my graph, and -9. So we're crossing our x-axis at -9, -5. And I'm gonna go ahead and answer question B. So -5, and then if we're writing these as ordered pairs, the y value is always 0, and then -9 as well. So to figure out the rest of the graph, we're gonna figure out the vertex. Yes. So there's a few different ways we could do this. So we could FOIL this out and figure out with our little vertex formula. So let's do that. So let's FOIL. Let's like distribute. So this is our equation. -x minus 5, x plus 9. So let's FOIL. So okay, so -x times x is -x squared. -x times 9 is -9x. -5 times x is -5x. -9 times -5 is -45. So that would leave us with -9x minus 5x would be -14x minus 45. Right, so if we want to find the vertex, we need to find the x value. So we use that little x equals -b over 2a. B is the 14, the -14. So if we plugged it in, it would be positive 14. And then 2 times a is the number in front of the x squared, so 2 times -1. So 14 over -2, so -7. So if we're talking about our vertex, X value is -7. To figure out the Y value, that's when we have to plug it back in. So we're going to plug it back into this equation, or you could plug it back to the original one, doesn't matter. So Y is going to be equal to -x squared. So we're plugging in -7 squared minus 14 times -7 minus 45. So that would be -7 squared is 49, and then the negative in front will be -49. And that would be positive 14 times 7 is 98, and then a minus 45. And that, if you add all that up, is 4. All right, so our vertex is at -7, 4. So we want to graph that. So go to -7 up to 1, 2, 3, 4. All right, so this is where we have to figure out like if we're going to do a solid or dashed line for our parabola. So this is where we look at our original problem. So it's equal to. So if it's greater than or equal to, it's a solid line. So if we draw this parabola, it's going to be solid. I cannot draw right now. Solid. If it's just the greater than, then that's when we do the dashed. And then it also says for part C, the solution will be shaded above or below the parabola. So if it is greater than, so greater than or equal to, that's when we shade above, because we want stuff above the graph. So we want the shading greater than my parabola. Okay. All right, so then we got into our systems. So for this systems of equations, we did some linear, we did some quadratic. So we want to graph both, and then we have to shade and like figure out where they overlap with the shading. So first I'm going to graph my linear equation. So this y greater than -3x minus 7. Now this equation is in our slope-intercept form. So it's y equals mx plus b. So m is the slope, and in this case, it's the -3. And then I usually, like when I think of slope, I think of rise over run. So if it's a whole number, I like to put it over 1. That way I can like rise -3 and run 1. And then b is your y-intercept, where your graph crosses the y-axis. And in this case, it's a -7. All right, so let's go ahead and graph that. So we always want to start at our y-intercept. So start down at -7, draw your little dot. And then our slope is -3. So we want to go up 3 and to the left 1. So we want to go up 1, 2, 3, left 1. So 1, 2, 3, left 1. 1, 2, 3, left 1. I'm going to draw a few dots. 1, 2, 3, left 1. 1, 2, 3, left 1. Yeah, 1, 2, 3. Okay. Okay, so we want to figure out like, is this equal to or not? So we are solid our dashed line. So it's just a greater than. So we want a dashed line for this one. So this one's going to be dashed. All right, so let's do the parabola now, our quadratic. Oops. Okay, so looking at our quadratic, the second one. Let's first find the vertex. So let's do x equals -b over 2 times a. So b is 6 in this case, right? Number in front of x. So -6 over 2 times number in front of the x squared 1. So this is -6 divided by 2, which is -3. So we got -3, comma. To figure out why, we plug that back into the equation. So everywhere I see an x, I'm going to replace with -3. So that would be -3 squared plus 6 times negative 3 plus 9. So that's going to be positive 9 minus 18 plus 9, which would be 0. So our vertex is at negative 3, 0. It's like right here. Which is also one of our x-intercepts. So for this one, because we like are on the x-axis, it's going to be, what we can do is we can use our axis symmetry. Axis symmetry goes through the vertex, so it goes that imaginary line that goes through negative 3. And we can use our y-intercept. Remember, the y-intercept is the c value on our quadratic, so this 9. So c equals 9, which is our y-intercept. So this is where our graph crosses the y-axis. So I can go up to 9 on the y-axis, draw a little dot, draw our point. And then we can mirror that point over the axis of symmetry. So because it's 1, 2, 3 units away from the axis of symmetry, we can go to the other side of the axis of symmetry, go 1, 2, 3 units, and there would be another point on our parabola. Okay, so I'm gonna get rid of this axis of symmetry line for purposes of this, because I only want my actual line. Okay, so it's equal to, so this case, we want a solid parabola. We don't want it to be dashed. Oops. Oops, I should erase my parabola. Oh, here we go. Okay, so now I'm gonna do the shading. Okay, so we want greater than the linear equation. So the linear equation is the orange line. So we want greater than that. So we want this area over here greater than it. And then we want less than the parabola. So the parabola is the green, so we want less than the parabola. And like technically this stuff is over here is less than, but we only want where they overlap. So we don't want that. And then we also don't want this stuff over here because that wouldn't be less than the parabola. So we just want the part where they overlap. So that blue and that red part. Okay, last one. Okay, so this is a system of 2 quadratics for this one. So for this one, all right, so let's start. Let's start with the first one. So let's find our vertex for this one. So let's do vertex of our orange one. So when x equals negative b divided by 2a. There is no x in this one, so b is technically 0. So there's no x, then it's 0. So 2 times a would be the negative 1. So our x value for our vertex is at 0. And then to find y, we plug 0 back in. So that would be negative 0 squared plus 1. So that'd be 0 plus 1, which is 1. So our vertex is at 0 up at 1, which is also our y-intercept. So let's try to figure out these the x-intercepts for this one. So I could factor. So to figure out x-intercepts, we factor. So factoring this one, so y less than negative x squared plus 1. First, we're going to take out a negative and make this x squared minus 1. So that is my difference of squares pattern. So difference of squares pattern means we do x and x, one's a positive, one's a negative, and then we do square root of 1, so 1 and 1. So my 2 x-intercepts would be negative 1 and positive 1 for this one. So that's where my graph's going to cross. So negative 1, positive 1. Go ahead, draw those dots. Okay, so then we want to do a solid or dashed line. This one is just a less than, so we're going to do dashed line. Okay. So the next one let's graph that one. Try the vertex first. Oops. So we're going to do, oh my gosh, I don't know why it keeps doing that. So we're going to do x equals negative b over 2a. So b in this case is that negative 4. So it would be positive 4 over 2 times a. A is just 1 because there's no number in front of the x squared. So 4 divided by 2, so 2. All right, so to figure out y, we plug 2 back in to our equation. So we're going to do 2 squared minus 4 times 2. So 4 minus 8, so negative 4. So our vertex is at 2, down at negative 4, so like right here. Right, so let's try to figure out the x-intercept. So let's do y is going to equal to x squared minus 4x. So let's factor. So this is a situation where we don't have like our c terms, so we just pull out a GCF. So I could pull out an x, make that x minus 4. So x equals, the x in the front gives you 0, and then the negative x minus 4 gives you positive 4. So this one crosses at 0 and positive 4. All right, so this is a greater than or equal to. So we want a solid parabola for this one. Okay, so we want to shade now. So the first one is we want less than that orange one. So we want less than this parabola. This part 2 in between. And then the second one, we want greater than the green one. So we want this part right here in between. And then that part above, technically, but we want where they overlap. So we don't want this. And we don't want this down here. So we want this middle part in between the two parabolas, because that would be less than the orange one, but greater than the green one, right in the middle. Okay, so this last question, using the graphs from part B, list 3 order pairs that are only solutions to y is less than negative x plus 1. So we want to look, this is the orange one. So we want to list 3 points that are solutions to just that orange one. So we could, and we wanted everything less than that. So we can look at this and just look and just literally look, put any ordered pair that's below that parabola, because it's only, we want only this a solution to that parabola. So it doesn't have to be in the solution set to both of them. So I'm just going to look down here. And it could be, like I said, it could be any point down here. So your answers will vary for this. I'm going to say down here, like 0, -3. That would be 1. Over here, -1, -4. And let's do one over here, like 1 down at -10 or something like that. So anything that was below that graph is fair game for that, because it's only in only for that one. All right, the next one, they want only x squared minus 4x. I guess this would be x right here. So the second equation. So we want anything above, because we want, it doesn't have to be both. So anything up there. So again, your answers could vary. So I'm gonna just look. So let's see. So we could do 0, 7. We could do 2, 2. We could also do like 4 up at 6. So all of those would be considered above that one. Okay. Last one is asking order pairs that are solutions to the system. So that is meaning order pairs that are in that little like area that we shaded. So, or could be on the green one, because like technically the green one is a solid one. So it could be on the green or in the shaded. So we could do like 0, 0. We could do, looks like 1, -1. And we could also do like 2, -4, because that's on the green one. That's the vertex. So anything on the green parabola is fair game because the green parabola is equal to, it's a solid line. The orange one is a dashed line, so we can't include any of those because we're not equal to in the system for that one.